Hi, this is Vikas Reddy from SVCA Bangalore. Today we are Today I am going to present about internship presentation on RAM memory design in Verilog using Fpga. Fpga nothing but field program gate array. Uh, we, I was worked in Core EL company which are from Kormangla, and my internal guide was Annay Gowda sir. Today we are going to discuss about the content certificate, introduction, objectives, planner for block diagram, flowchart, software components, advantages, disadvantages, applications, results, conclusion, references. This is the company profile which I worked in this company, Coreal Technologies Embedded. In this company, they provide us to develop the programs and accurate results they are presenting in this company, and the company outcomes are defense and aerospace, digital video solutions. These are digital video solutions under comes under the system Verilog and HPC and higher education markets. Coreal technology is driven by innovation and a multiple disciplines approach towards technologies. Introduction. I did internship in this company for 1 month, and I learned system Verilog. In that system Verilog, I choose one program was the RAM program. In this RAM, we discuss about briefly. Random access memory is the best known for computer memory. This is an volatile memory, like it is an temporary memory storage. If we stored anything in this, and suddenly the PC or the system will be shut down, the uh, data will be removed. If this is mainly used for fast response. Nowadays we are using mobiles. In these mobiles we are using recent apps. Those recent apps run by this RAM memory only. If other apps will be closed and again we have to open, means the process will be late, and the system have to run the data from SSD or HDD, and RAM is a little bit faster than SSD, and SSD is nothing but solid state drive. In this RAM we are going to use about two ports. One is single port and dual port. In single port we can only write one at a time, and we can't write and read. In dual port we can both at a time read and write operations we can do. These are the objectives: to verify the design in functional correct and meets the specific requirement, to identify and locate the design issues such as bugs, errors, mistakes, or any issues in this program we can rectify, and to ensure that all design functional requirement have been implemented and tested, and to improve the reliability of design identification and correctly issuing that causes failure or errors. This is the plan of work which we did in company. We did almost 4 weeks. In 4 weeks, we did only Monday to Friday. First week we just referred how was the company, how they are working, and how was the which is the software they are going to use, and we learned everything in that on first week. In second week, we used to learn some of the small things like system Verilog, HDL, and embedded system applications. These all will be learned, and we learned some of the coding, how they are going to code, how they are um, referring that code for the applications. All these we learned in second week. In third week, we tested the code and bench in Verilog HDL test bench for the conditional and sequential logic and digital video solutions, everything which we referred in applications. And in third week we learned about FPGA mostly. In fourth week we learned about 7000 SOC architecture is which one is famous. Project implementation on remote FPGA boards I did. It is the plan of work which I did an internship in this company. And this is the block diagram. Left one is the single port diagram and right one is the dual port diagram. In single port diagram we can see right only one data, one data, one address, and V is nothing but a write or write clock, and Q is the output port. Only single output ports are there, and 4 is the input ports and the Q is the output port. And RAM is a combinational circuit for a multiplexer and decoder that has a maximum number of 2 power n address bits, and selection lines are single output line. And we can see in right side diagram it is an 4 bit 4 cross 8 bit dual port RAM. And we can see here data bits are A port and B port, address are A port and B port, and outputs are also A port and B port. And here also we can see write port also, write enable port also have A and B. Clock is only one. RAM is a capable to perform two operations like read and write, means single transform out, and write means single transform in. RAM permits one of these control signal internal circuits that is embedded into inside memory, which are divided many types. Nowadays we can using many of we are using laptops, PCs. We can see it is has a RAM has 4 core, 8 core, 6 core, 16 core, or in Ryzen series they are sending telling us threads. If we have less threads, the computer memory will be less performance, I mean speed will be not matched to up to the mark, because the threads, the cores or threads will be the main performance in this RAM. And if we can see more threads in 16 GB or 32 GB RAM, we can see more threads, there are more cores. If the core will be divided the work in equal parts. If we have uh, 8 cores or 16 core, the performance will be much difference in this 8 core and 16 core RAM. These are all will be explained in flowchart. Here we can see the mm, read pattern. And we have both operations in RAM, right? Read and write operations. In read operation, the scheduler uses the read pattern algorithm to determine which to survive the battery bank. Bank is nothing but the memory. Here we mention as bank, which to serve the data bank. The read pattern builder selects the memory request to survive the determine how requests survived by the banks will be decoded. The algorithm is designed to survive the many read requests in single memory cycle. This all will be implemented read in pattern only. Here we can see that flowchart. If we start I is equals to 1, means initially we are giving 1, and then the 1 or equals to 1 or less than equals to 1. If a data bank, I mean code will be recognized and it sends if 1 equals to 1 or less than 1 means it is the S, or no means J equals to 1. Like here we can see, right? Comes to the down, J equals to J plus 1, and finally the loop will be complete when the pattern is equal. And here we can see the write pattern flowchart. In this battery bank allows the memory controller to survive the additional write request per cycle. In a cycle we can write only some of the numbers, or we can write only um, not much of bits. We can write only 1 bit or 2 bit or 4 bit, like this. When multiple writes target single bank, it can commit some of them to battery bank nothing but RAM memory. The access scheduler implements a write pattern to determine the right request to scheduler and single memory cycle. Every single memory cycle can request to determine the to request them to schedule implement the write pattern. Only when the write bank queries are nearly full does the access to pattern builder, and the software requirement which we used in this program, Quasta. uh, in this Quasta we mainly use for FPGA, and so we have mainly used this in FPGA because of it is very familiar to it, and it can be used powerful to write a program and speed and verification and debugging of complex in in this FPGA program for that only. These are the advantages: increasing the speed of system efficiency, multitasking, reliability, and flexibility. And other chips will be like MBs are 1 to 2 GB only. In this RAM memory, we can use up to 1 to 256 GB RAM memory, but we are using mostly 32 GB in RAM memory. And disadvantage, volatile memory. If we switch off the laptop or PC, the memory will be deleted, and limited space of storing data because we can't provide much data in this. Required power to store data. Some of the power have to store in this. No, power have to consume for this storing data, but in SSD or HDD we can't provide power to that. We have to share the data into that external memories. Applications, uh, that field program FPGA using in RAM. The RAM will be this program using on FPGA mostly used in these applications only, like logical functioning, gaming, video and image editing, web browsing, database management. All these are the high performance things for those only using the main RAM. Results in this system Verilog, we're implementing several constraints. One popular approach is to use an array or register logic variable. RAM test bench typically included inside various sets of RAM module. The pattern are designed to test the different memory access patterns such as sequential, random, or inertial access. When using RAM, it is important to flow the instructions carefully and to ensure that RAM module is properly installed and configuration. Quasta Advanced Verification is powerful simulation and verification tool that is widely used in electronics industry for developing and verifying digital design. And we can see here the output of a single port RAM. This is the simulation which we did in a company, just we pasted here, and we can see here this is a waveform of a dual port RAM. In this dual port RAM, first we have to give some of the uh, address or data. Then we can see here WA and WB. One is the read mode, one is the write mode. Here when we are going to read or when we are going to um, write, all these are in test bench content only we have to write, and these are the outputs which we referred in that. And in conclusion, in this project, about 64-bit cross 8-bit single port and dual port design as common read and write addressing Verilog HDL or system Verilog. Synthesis tools are used in this single port, and there is a system Verilog code and automatically interfere either depending on the architecture of target device. The circuit implementation in FPGA is such faster and efficient to general CPU such as the real-time system and implementing in FPGA. These are the references which I referred from online, and this is the link which I referred in online. and I learned much thing in about RAM and ROM also, but I referred only prefer to present on only RAM because I did a project in I practically did on RAM memory. And thank you.